In the Congress of Mathematicians in 1900, David Hilbert gave an address, and he presented 23 problems that he felt would stimulate mathematics over the next century. Pretty much all of these problems had been addressed by the 1970s, and they really did stimulate mathematics. And this led the mathematicians to start up a new group with a new set of problems. What was interesting was that Ron Graham, who was a discrete mathematician, observed that all of the problems that were being proposed were continuous math problems, and that in fact the problems that were in discrete math, very simple problems like what is the most efficient way to stack oranges in a grocery store, and it's exactly the way you think it is, but try and prove it. That Ron Graham and the other discrete mathematicians proposed a number of problems that were, they felt, just as challenging as the ones that were being proposed by the continuous mathematicians, and would stimulate mathematics even more because they would go into these new directions, not be nearly so much same old, same old. And so it goes. And in fact, that's come to pass, and there's been a huge amount of activity, especially in this area in discrete mathematics, of trying to show that what the relationship is between problems that are so-called easy and hard, or the terminology goes NP complete, P complete, NP hard, NP easy, and so forth. As one example of these problems, try and construct a route for a salesman to visit all of these cities given an arbitrary set of cities. And it's easy to show that this problem is in computationally ridiculous. If you get 20 cities, 20 factorial is some gigantic number that you cannot possibly go through every possible route. And yet, people have proposed heuristics to this that are very fast, very efficient, and they don't get exactly the closest route, but they get something that's arbitrarily close to it. And so you see the difference in what's hard and what's easy.